So now we will move on to some combinations questions. So in this first question, it's essentially saying we want a group of 5, a group of 7, and a group of 4, and there are no restrictions. So we would do 16 choose 5 multiplied by 11 choose 7, and then 4 choose 4. So that would give us 1 4 4 1 4 4 0. That's easy. No restrictions is easy. Now to select a group of 5 with at least 2 boys. So we can have 2 boys, 3 boys, or 4 boys, because there are only 4 boys in the class. So what we would do here is there are 4 total boys, so we do 4 choose 2 multiplied by, so this is now the girls, 12 choose 3. And then we add this to 4 choose 3 times 12 choose 2, and add that to 4 choose 4 times 12 choose 1. So 4 choose 2, that's 6. So 6 times 12 choose 3 is 320. And then say 4 times 12 times choose 2 is 264. And add that to 12. So that would give us 1, 5, 9, 6 ways. And select a group of 6 if 2 girls refuse to be together. And this is an example where I would instead do total arrangements, subtract the ways they are together. So when we want 2 particular girls, or 2 particular people or objects to be in a selection, we just leave them out, because we know they're already there. So they're already in the selection. So that means we only need to select 4 more people. And that is just 14 choose 4. So, and the total way would be 16 choose 6. And that gives us 7,007. Now here, in the next question, we've got a bag of 6 red fuses, 5 blue fuses, and 4 yellow fuses. And we want 3 fuses of different colours, it says here. So that would be, you'd do 6 choose 1 to get a red fuse, 5 choose 1 to get a blue fuse, and 4 choose 1 to get a yellow fuse. So 6 times 5 times 4 is 120. And then B is 3 fuses of the same colour. And so, case 1, all red. Case 2, all blue. Case 3, all yellow. So this would be 6 choose 3. This would be 5 choose 3. And this would be 4 choose 3. So this is 20, this is 10, and then this is 4. So 20 plus 10 plus 4 is equal to 34. Then C. Okay, 10 fuses in exactly 2 colours. Alright, so here's when I would draw maybe a bit of a diagram. And so for C, I'll show you 2 different ways. I'll show you probably the simple way. Do RBY and think of the ways we can get 10 with only 2 colours. Now, if we do 6 red fuses, we could do 4 blue, then 0 yellow. But we could also just do 5 and 5. But then we could also do 6 and 4 with the yellow. So this would be 6 choose 6 times 5 choose 4, which is equal to 5. Then 6 choose 5 times 5 choose 5, which is 6. Then 6 choose 6 times 4 choose 4, which is 1. And 5 plus 6 plus 1 equals 12. That's one way, and it's an absolutely correct way. But also, maybe you could think, well, there are 3 ways you can have 2 different colours. You can have red, blue, blue, yellow, yellow, red. But if you had blue, yellow, there are only 9 total there, so that doesn't work. So you've either got red and blue, red and blue, and yellow and red. And so, essentially, out of that red and blue fuses, you want to pick 10. There are 11 total. So you do 11, choose 10, and then you add that to the red and yellow fuses, choose 10, which is 10, choose 10. That's 11 plus 1, which is 12, which gets you the same answer. And now for D, 9 fuses in exactly 2 colours. We can apply similar logic, but now we can also do blue and yellow. So that would just be 11 choose 9 plus 10 choose 9 plus 9 choose 9 now. So this is just 55 plus 10 plus 1, which is 66. Now this question. This can be a bit time consuming, but if we just barrel straight into part 1, you need at least 3 mathematicians and at most 2 physicists. So if I do MPC for mathematicians, physicists and chemists, I'll start at having 3 mathematicians, because I know I have to have at least 3. And I'll just do the least possible numbers of physicists and then increase them. Okay, so I could have 0 physicists, and then I could do 4 chemists. Then I could instead do 1 physicist and 3 chemists only. Then I could try and do 2. And then I couldn't go any further because remember it's at most 2 physicists. And now I'll move on to trying to do 4 mathematicians. And I think you get the idea. And we can, and there's only 6 mathematicians, so we can stop at 6. And then you just calculate the combinations. I'm going to write 6, 5 and 4 up here, so we don't have to keep scrolling back and we don't forget what numbers we're actually doing. So 6 choose 3 times 5 choose 0 times 4 choose 4. Because we're choosing out of the 6 mathematicians, 3 of them, then we're choosing none of the 5 physicists, and then all 4 of the 4 chemists. Now, what's left for us to do is to evaluate these and then just add up the number of combinations. Now, for that first one, I will factor it. You can factor out that 6 choose 3 because it's common to all of them. We've got 1 6 20 for there. And now we'll add them all up. And I believe that will equal 2955. Right, okay. We've that's sorted out. I'm gonna just shrink this down a bit because we need the space. For the other questions. So how many selections in Permutations is exactly one chemist chosen? Okay. All these ones. Okay, so it's just 6 choose 4 times 5 choose 2 times 4 choose 1 plus 6 choose 5 times 5 choose 1 times 4 choose 1 plus 6 choose 6 times 5 choose 0 times 4 choose 1. So that's equal to, alright, 6 choose 4 is 15, and that's multiplied by 10 times by 4 plus 6 times 5 times 4 plus, that's just 4. So that's, this is 120, that's 4. And that's 40 times 15, so that must be like 600. So that gives us 724. Then for the third one, team of 7 is now chosen from random at all, from all 15, choose 7 possible teams. Okay, it's just 2955 over 15, choose 7. Now you can write something like, oh, probability equals, but too much time on such a simple question. So now we're on to this question. The mathematics teacher has 10 different posters, but you can only put up 5 of them. He's got 3 posters on algebra, 2 on calculus, 5 on trig. No restrictions first. It's 10 choose 5. Which is 252. So, not going to put up either of the calculus posters. We can just take them out of the selection. 8 choose 5. Now for C, you could try different approaches, but the approach that works is by doing unrestricted and subtract the ones where you've excluded at least one topic. So, in which case, we'll do figure out the ways that we can only do 1 or 2 topics. So you could have only so then that would be, you've got 5 lots of them, choose 5, and that's 1. Only algebra and trig. That's 8 choose 5, which is 56. Only calculus and trig. 7 choose 5, which is 21. Now, here's where we do need to be careful, because when we're doing only algebra and trig, we could have 5 trig posters, couldn't we? And if we did only calculus and trig, we could also have 5 trig posters, which means we will have to subtract 1 to account for that. So and so then we simply do 252 minus 77, which is 175. Now, going back to that table question that we did in the last video, we'll go back to A, which is a combinations question. So, regency must sit in the same table, then tan wants to be in the other table. Perhaps there's a bit of beef there. But as you saw in the last video, they appeared to resolve the beef. So, okay. Alright. Now essentially, if we just say on X we got R and S, we need the other two, and then Y we got U4. And remember, tan must be on the other one. We've got 5 possible remaining people for either the last 2 of these last 3 seats. And because of the symmetry of Pascal's triangle, it doesn't matter which way you do it. So let's just say 5 choose 2. But remember, you could also swap X and Y around. So you'd have to multiply it by 2. So that's 20. So another fairly straightforward question, but it may be a bit time consuming, like the one with the mathematicians and the physicists and the chemists. Let's see, it must have 1 swimmer, so that's helpful. Now cyclists and runners. It's got to have at least 4 cyclists. There's 5, so that leaves 2 runners. 5, 1. And I'll write up the numbers up here. And then, okay, do 1, 6, 0. All good. And because that all 3 have a restriction and S swimmers must be exactly 1, I think that's it. So 6 choose 1 times 8 choose 4 times 11 choose 2. That is equal to 23,100. And then that final one. That's 168, and then you add them together. $26,964. So that's it for the combinations questions. In the next video, we'll move on to using perms and cons for probability.